And we're live. Welcome to the live chat for Wednesday, January 17th, 2024. I think we have a lot to talk about tonight, and it has to do with Norlawn troughs in general, inverted troughs that can create quite a bit of snow for some locations and frustratingly very little snow in other locations. Tonight, we're going to be live on YouTube, of course. We're going to be live on X. See if I can make sure. I'm going to see if I can follow along on X on here as well so I can answer questions. So if you have questions on X, please definitely ask them. Same thing on YouTube. I'll be here to answer those. And first and foremost, all questions will be answered on the premium chat. So if you are a premium member, you're guaranteed to get all your questions answered, except whether or not I think the Chiefs will win this weekend, because this weekend versus the Bills will most likely be a war. Probably 34-33, something like that. So it's going to be crazy with that game. And there'll probably be snow showers as well, just to make it even more fun. But tonight, you are not here about my thoughts on football. You are here about a inverted trough, because you might have heard that we have some interesting weather and we have some very interesting model guidance. So how do you go about forecasting for these very difficult, very complicated troughs? Because obviously out in the public, you have all sorts of models. You got the GFS, you got the UK Met, the Korean, the NAM, the HRR, all these different models. And the way to go about this is that you don't just stick with one model. What you want to do is combine them. And I'm going to show you how to do that and walk you through my thought process. And because you are here tonight, I'm going to show you what I have forecasted so far and what I think I might have to change, what I might not change, and go from there. So premium consulting members, you guys have had the map already. And as a premium consulting member, you can zoom in down to literally your address. This was a response to people constantly asking me how much in my backyard. Now you can literally zoom down to your backyard and then just click and there's your forecast. So that's why I have that set up. So let's take a look at all of the data, shall we? And we start off with the infrared satellite picture. Now, the reason why you want to use an infrared satellite picture is you want to see the nature of the short waves that you're working with here. And what you want to do is understand the lifting involved here. And the best way to determine lifting with the infrared satellite pictures is to see how cold these cloud tops are. And on the first shot, pretty good short wave out here. Not bad. Sets up your thermal gradient. Sets up the interaction with the Arctic air mass. And then you got this short wave that's starting to move over the Rockies. It looks pretty vigorous. Taking a look at the upper level winds. And yeah, that's pretty strong. Very impressive short wave here. Now, the polar jet stream is very wavy. The subtropical jet stream is active as usual. Not going to be a full phase this time. The short waves here are a little bit out of sync here, especially this one out here compared to this one here. If these two are a little bit more in line, this would probably be a more significant nor'easter. But because of this feature here, it keeps this ridge displaced. So you don't have enough time to really phase everything together to create a monster storm. So that's why we're not seeing a major nor'easter out of this. But we do have the block here to slow things down. We have our upper level low or tropospheric reflection of the polar vortex, pretty much where you want it to have it happen, right around the Hudson Bay. And you have plenty of activity here with this trough. So you have a nice broad trough. You have a fast flow. So this looks like more like a positively tilted trough, which is important because it tells you, okay, this is going to be a fast moving short wave, but it also increases your potential for stretching in the atmosphere if you have the right conditions. We'll get to that in a moment. Let me go back here and water vapor satellite picture. Okay, what do we see with the water vapor satellite picture? Very vigorous short wave. Interesting. Another short wave here, very vigorous. Plenty of moisture in the subtropical jet stream. Don't need a phase to tap into this moisture. So you have the moisture available here. And of course, you have your Arctic air mass in place. Very fast moving progressive flow over the United States, blocking up in the Atlantic. So it kind of gives you an idea of this is a pattern where, again, you would support your positively tilted trough. So anything with a negatively tilted trough associated at 500 millibars, you throw out. So some of the earlier guidance where you had the negative tilted trough, that's where and it had like a major nor'easter. That's where I threw that guidance out, and I wasn't really talking about that type of scenario because it doesn't match the pattern configuration that's in place right now. What you would need for that to happen is a very large ridge to be dominating the Rockies, and you're just not having that right here. So you throw that out. So that's gone. So you can eliminate that from your model selection. So now what you do is you have to answer two questions, a synoptic question and a Meso-scale question. And this is where a lot of people go wrong with model use, is that they look at one particular model and then they stick with that model all the time. Now, you probably have noticed that I use the European model guidance quite a bit. The reason why I do that is because synoptically, it tends to perform the best. It has the best data ingestion and typically performs the best. It's not foolproof. It's not perfect in any way, shape, or form. And you have to keep an eye on all the other guidance as well. Sometimes the European guidance lays an egg. It happens. But more often than not, it does not. So it's a pretty good guide on what is evolving. Now, you don't just copy and paste it, but you take a look at it and then you evolve and then you put your own spin to what the data is showing you. So what you want to do first is take a look at the upper level winds. And let's get to Friday morning. And this feature right here is a jet streak. Jet streaks are very important. When you study a jet streak, you want to look at this part of the jet streak and this part of the jet streak. These two areas here is where you have your rising motion, your lifting motion. So if you are forecasting for an area and a jet streak is under this area, then what you could expect is strong lifting. So when we get to the afternoon hours, what do we have set up? Here's your jet streak right here. Here's one area of lifting. Here's the other area of lifting. Basically over just the south of Long Island, central and southern New Jersey, Delmarva Peninsula, southeastern Pennsylvania. So why is this important? Okay. So synoptically, we found the area of strongest lifting for upper level winds. This is your divergence and your diffluence, the ability as air is rising to exit out. So that exiting out process, what it does is it allows for stronger ascent. And the stronger ascent is focused right in this area. Then you take a look at the mid-level winds, which is 850 millibars. And something very interesting shows up on the European and the GFS guidance. Because of what's happening with the changes in the mass at the surface, you're getting a stretching in the atmosphere. Okay, and so you have your strong upper level winds here creating rising motion, right? And you have a very strong thermal gradient at the surface, i.e. your Arctic air and the Atlantic Ocean. So that leads to a very powerful thermal gradient. And the stronger the thermal gradient, the stronger the low-level rising motion. So the synoptic model tries to handle that by creating this signature here. These winds coming in from the northeast and backing out. It's even stronger and more detailed on your Meso-scale model guides, which we'll get to in a moment. But what this tells me is that the model guidance is trying to resolve this stretching. And the way that the synoptic models try to handle this, because the resolution isn't as intense, as good, okay? This is basically HD TV. Next, we're going to look at a 4K TV, okay? That's the best way to describe it, okay? So your HD TV says, okay, they're stretching the atmosphere here. We're going to create some funky little wind set up here as a result. And so what it does here at 850 millibars is that it's taking winds off of the Appalachians and cutting it across the coastal plain, which would explain why the QPF on the European guidance is not as impressive, because it's assuming that winds are coming off the Appalachian Mountains and basically drying out the atmosphere, which isn't what's going to happen. But you can understand why this is happening, because there's so much stretching and moving in the atmosphere that the model guidance is trying to handle it. And the resolution isn't strong enough to handle what's evolving here. So it overemphasizes this motion. So what really is a convergent and confluent flow at the surface, and then a divergent flow in the mid-levels, really ends up being this weirdness showing up at 850 millibars. So that's part of the synoptic question. The other thing you want to look at is the 500 millibar PVA. Now, this is upper level lifting, positive vorticity advection, right? So when you have positive vorticity advection, that means you have strong lifting. And what we have set up here on Thursday night into Friday morning is PVA that's a little bit stretched out, but then this short wave right here catches up to the frontogenesis that's in place at the coast and is amplified just enough. Now, let me go back here, right here. Okay. This part's important. This signal here looks like a little bit of convective feedback, but it's also a sign of that stretching and pulling in the atmosphere. So think of the atmosphere like taffy, right? And as you're pulling the atmosphere between this feature here and this feature here, you're creating stretching in the atmosphere. And that stretching is causing rising motion, because remember, the atmosphere is always looking for a balance. So as you're stretching the atmosphere, you're creating holes in the atmosphere, so to speak, and air is rapidly rising to fill that holes up. So as a result, as that rising is intensifying, you're getting more lifting, more vorticity. So that's why you're seeing this signal here. 700 millibars, a little bit more finer. 850 millibars, a little bit more finer. So, what is the synoptic model telling us? Well, we have a positively tilted trough at various portions of the atmosphere that's trying to pull lower heights back to the west. That stretching in the atmosphere we know is causing rising motion. Meanwhile, we have a jet streak at the same location enhancing the lifting motion. So right now we have a lot of forcing, a lot of lifting at the mid-levels and at the mid-Atlantic. And we know where that focus is. We know it's from the Delmarva Peninsula up to the central New Jersey coast. So we know it's not towards New York City. Sorry, guys. We know it's not towards Baltimore. Sorry. We know where that forcing is. And we have an agreement on the general idea of that forcing on the GFS, European, Canadian, you have it. They all pretty much have in the same ballpark, the same area. So that's where we use the synoptic models. That's where we use it and then we stop. Because what we're going to be talking about next, you have to use more of the Meso-scale models. And this is where we start to talk about moisture and then lifting at the lower levels and the skew T and the potential for instability. So that's our next question. So now we got the synoptic, so everyone understands that. Now let's talk about the temperatures. Okay, now the European, remember what it was doing with the winds. Here's at 925 millibars. I like the idea of warming here. And then you can see the cold air crashing down. At 850 millibars, doing the same thing. Notice the gradient here, very impressive. Again, synoptic model, but you could still use it. But let's take a look at the Meso-scale model. And this tells me a lot more. Now, when you take a look at this, and I hope it's zoomed in enough. There we go. Zooming in even better. Okay, so you might look at this and say, well, everything's below freezing. Snow. Okay, fair. Look at the different pockets here. You got a very cold pocket here around central New Jersey. Warmer pocket, colder pocket in southern New Jersey. Warmer pocket around, let's say, the northern suburbs of Baltimore here, right around Chesapeake Bay, southeastern Pennsylvania. Colder pocket over east central Pennsylvania. So what's happening here? This isn't uniform. This is a sign of convective lifting, convective rising motion. Why do we know that? The reason why we know that is that we're seeing colder pockets and warmer pockets. Why is this important? When you have rapidly rising air, it cools the atmosphere. But at the same time, when you have sinking air, it warms the atmosphere. So the models are trying to resolve that motion by creating this signature. Now, I'm not saying that this signature is going to be exactly what's going to happen. Because if that happened, hey, this model, the NAM for tonight, gets a gold medal. Because that is extremely hard to forecast. Because you got a lot of different factors, a lot of chaos going on. You got factors of ocean dynamics. You have factors of wind dynamics. A lot of things going on. It's essentially forecasting a thunderstorm 2 days out. Very difficult to do. But what it does tell us is where that convective motion is occurring. So that's where I like to use 850 millibar temperatures. Because we know now that that process is happening based on what we're seeing with this signature here. Out here, you can see the influence of orographic lifting and sinking. So you have that process going on around here. So around here, they'll probably get 6-8 inches of snow pretty easily out towards West Virginia. Then you got pretty much a light snow signal here. Why do I say light snow signal? Well, because if I'm having a lot of lifting here, I got to have sinking air somewhere. Right? So let's just consider that for a moment. Sit back on that. That's also going to be an issue up here. So we have that signal in place. The next thing we want to look at is moisture. Much like the other storm, moisture's availability is going to be a big factor. So by the time we get to Friday, on the European guidance synoptic model, there's clearly a push of moisture here, but it's not as organized, and it has that influence of that westerly wind coming off the Appalachians, so it's a little broken. But you get the idea here. There's clearly a signal that there's moisture trying to get pulled towards the coast. The model is having a hard time resolving it. And again, the European is one of the better models out there synoptically. So it's clearly a sign. So let's take a look at the NAM model guidance. Again, Meso-scale model. We're not looking for perfection. We're looking for clues and signals. And the clues and signals clearly shows a drawback towards the coast here of moisture. But there's a pretty significant cutoff here. And again, we're not talking about deep moisture here because we have a very cold, dry air mass. So we're seeing moisture and warmer air get pulled towards the coast, which is going to be an issue for the immediate New Jersey coast. But we're not seeing a huge explosion of moisture. It's very focused. So this tells me, yes, there's going to be moisture available, but it's most likely going to be focused. And we also know that there's convective capabilities here based on the 850 millibar temperatures. So we got moisture, we got lifting, we have temperature signals. Okay, so let's keep on adding. On the European signal here, you kind of have some idea here of, here's your mixing signal right here, your warm air getting pushed towards the coast. Here's the model trying to resolve that trough And we can move this forward. You can see the enhancement of the snowfall here, trying to handle that lifting. Again, under the same location as the jet streak. While that's happening, at the surface, you see your northerly winds. And note, let me try and get to the winds. Okay. Note, there's clearly a convergence towards a trough here that's setting up. See how the winds are going due from north to south, converging into that trough? So we have cold air feeding in. Our temperatures, when we're looking for wintry mix on the coast, this is going to be more like 32, 33 snow, sleet, and a little bit of rain. Not going full over the rain. So you'll have snow, sleet mix in, a raindrop or two, back over to snow. It's going to be a bit of a mess. On the immediate coast, that's where it's going to be very, like if you're on the beach, it might be a little hard for accumulation. If you are 4 streets in, you'll be snowing accumulating just fine. That's how tight it's going to be in terms of that gradient, temperature gradient. On the NAM guidance, let's see here. This is the development. Okay. So what is this showing us on Friday afternoon? Heavy snowfall, moderate snowfall here, but notice the signal here, this breaking up. Okay, so why is this almost gone? This is starting to break up. Well, this is telling me we have very intense lifting here. This is probably a little overdone. I like this signal here. This makes sense because if you're having really strong rising motion here, you have to have sinking motion here. You have to have sinking motion here, but this might be a little bit overdone. Let's see what the HRR is doing. And it's kind of pulling off the same signal. This is probably a little too warm. This is probably snow, sleet, and rain rather than just rain. Probably some bright banding signals in this guidance. Very intense band of snow. Lighter snow. Again, this, I think there's going to be a little bit more snow filled in than what's shown. This is probably going to be more scattered. But this tells you the intensity. So now let's go to the next level. Okay, so now we see what the model guidance is trying to do. Let's look at this in a 3-dimensional way. Or really 4D if you really want to just think about it and just kind of look into your mind's eye and just look at all the data, right? So you could see it right here. You can see the jet coming across. You see the stretching in the atmosphere here. The moisture's coming in here. So you have all those factors coming together, creating lifting, rising motion, stretching. What does that look like on our SKU-T? On the NAM, that showed up. I've been studying BuffKit on this, comparing this to where the snow growth is. And what really stands out to me on Friday afternoon is this convective signal here, up to roughly about, let's say about 850 millibars. So you have rapidly rising motion, convective signal on the NAM. And you have the same signal showing up on the HRR. So what does this tell us? This tells us that we have potential here. We already saw it in the 850 millibar temperature prog of strong lifting. We now see it on the SKU-T. So what we know now is that there will be intense banding for a short period of time, let's say between 12 and 6 p.m. on Friday. And that banding is going to enhance snowfall. But understand what that banding means. It's going to be very difficult to forecast. You know where it has the best potential of setting up, which is central New Jersey, southern New Jersey, southeastern Pennsylvania. You don't know whether that band sets up in Monmouth County and an ocean misses out on a lot of snow, or if it sets up in Ocean County, Monmouth County gets light snow, Philadelphia gets on the edge of it, but northeast of Philadelphia gets barely nothing because of strong sinking air. That's all got to be nowcast. You might get a better idea once you get like 12 hours out, but even that's going to be difficult. So now that we have all those factors, What did we do? We took the synoptic model and we solved the synoptic questions. We took the Meso-scale models and we solved the Meso-scale questions. Now that we have those answers, now we combine them into a forecast. And you don't just use model A or model B or model C. You have to use all the solutions based on the data that you have. So when you're creating a forecast, it's never like, I'm just going to look at this model and then copy paste. You have to look at all the models, understand what's happening. You can use your little cheat code and use, like, let's say, the National Weather Service. NCEP puts out an amazing discussion on for any models that are acting a little wacky. Like, so for example, first thing I do in the morning is I read a discussion from NOAA about whether or not, like, if data is missing for the GFS, or if the GFS is way off and the European model and the Canadian agrees, or the Europeans are acting a little weird and follow the GFS. That's a great resource so that we can cut down about 2 hours worth of work, because they already do it for you. And trust me, I don't get enough sleep as it is, so if I could save 2 hours, that's great. Yeah, I know. I'm working on it. That's one of my resolutions, is to get more sleep at some point. Some point this year I'll sleep. I don't know. All right, so now with all that, let's take a look at our forecast. Now, premium members, as you know, you can go right to this map right now on the dashboard. You can zoom right into your house and have a go at it. But this is going to be kind of a preview to the public map. I'll probably make some tweaks to it tomorrow morning based on 0Z guidance. But the general idea, remember what I said about the subsidence? So a trace to 2 inches up here towards Connecticut, Hudson River Valley, those locations. This area right here, you have some enhancement of jet streak dynamics and some of the short waves moving through. So I like 1 to 3 inches. I think a lot of people are going to be around 1 inch here. Like Scranton, you might get 1-2 inches. New York City, maybe an inch. As you head towards Allentown, better chance for 2 inches. But this is a type of gradient where you go from 1 inch to 6 inches very, very quickly as you go south. Now, in this zone here, this one might be where I have to tweak it a little bit. I got 2 to 5. I might cut this down a little bit and then have a 1 to 3 swing in behind here. I'll have to work on that tomorrow morning. But just a general idea here, 2 to 5 inches in here of snow. I think a lot of people like around Washington probably going to be at a 2-inch mark. A lot of people around Delaware, maybe that 4-inch mark. So I'm going to have to fine tune this a little bit. Then this is where things get a little bit more tricky. This is my 4 to 8 zone. Now, I know that other providers, National Weather Service and whatnot, probably haven't touched 8 inches yet. Why am I doing that? With convective banding, there's going to be enhancement and someone's going to get walloped. I don't know where, but somewhere in the zone. In this zone here, you have a combination of jet stream dynamics, moisture advection, temperature gradients, and stretching in the atmosphere. So, all of it. So, if that's all those zones, then what you'll see there is somebody getting hit with some very heavy snow. And someone in this location is also going to get, for lack of term, screwed over. Because there's going to be very intense banding somewhere in this zone here. And someone's going to miss out with flurries for 2 hours, 3 hours, because the band is sitting just to your north. So you've been warned that could happen. Don't know where. We're going to have to nowcast that. But you've been warned. That's the type of scenario we're dealing with here. And then right along the coast, I have 1 to 4 inches, wintry mix. This is an area where, let's say, let me zoom in here. Let's say Long Beach might get 1 inch, but Stanford Township or Little Egg Harbor gets 4 inches. It's going to be very, 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 very tight gradient. Atlantic City, 1 inch. Edwin, Florida's National Wildlife, 4 inches. It's going to be that sharp. So it's going to be very interesting to see how that mix plays out right along the coast here. But that's the general idea with this forecast. That's what I'm thinking. This is how I came about it. This is how I usually go through my process of trying to figure out what to do with this forecast. So now that I've gone through everything, I am going to go on the chat board here under the premium dashboard. I will answer all the questions here. Then I will go to, wow, 232 people. That's pretty good. Then I will go to YouTube and answer some good questions. And we'll see whether or not X actually helps out here with answering questions here. I got 2,313 views, 318 views.
232 people on YouTube, and now you're 99 on X, 98, 95.
Wow.
You're jumping, you're fluctuating.
Well, there we go. Okay, so, and then I'll get to the questions over there as well. So let me handle live chat as well. Pat Conway asked, this might be a little old, but after Friday, is winter over? Short answer, no. I'm not really focusing on long range today because there's a lot to go over with what's going on for Friday. But the short answer is no. We are going to be getting a break after this. We're going to have our little January thaw that we normally have, and my car could use it because it's under ice right now. But we will have that thaw. February is going to be a very tricky month. It's going to not the best high latitude blocking, but possibly better tropical forcing. So we'll have to watch to see how that evolves. I do like the idea at the end of February and March will feature spring coming on strong because El Nino is weakening rapidly. And I think there's going to be a lot of changes going on in the atmosphere. So February might be like winter till February 20th, 24th, something like that. And then boom, off to spring. So, which could be a rather wet one, but we'll get to that later. Thanks so much for all your coverage, your services. No problem. That's what I do. Thank you for watching because it allows me to do what I love. Regarding the storm, are there factors that decide where a Norlon trough sets up, or is it just a matter of luck? It matters depending on a lot of the factors we're talking about, where the upper level winds set up to support the stretching, how the trough stretches. Based on everything that we're seeing, that's why we're focusing on southern New Jersey. If we're 15 miles off the coast and out of the mixing zone, wouldn't that mean that we won't necessarily have the highest ratios? Great question. Okay, so here's the thing with ratios. And let me fix this real fast. Okay, so with the ratios, when you have strong lifting in the atmosphere, what's happening is that rising motion is cooling the atmosphere. So where you're under that strong band, your snow ratios are going to skyrocket. Outside of the bands, your snow ratios are going to crash. And that's where sometimes you'll mix in with a little bit of sleet as well. Because what's happening is that sinking air and that warm air that's occurring is going to reduce your snow ratio. Sometimes it goes down as low as 6-1, while within the band you're as high as 20, 25-1. So it's very, very chaotic, very volatile. Let's see. Thank you for the spot on no hype weather discussion. You're a beacon in the fog of social media hype. Well, that's the objective. I appreciate it. And winter storms do not have names. That is true. That is true. Winter storms do not have names. They better not be naming this one. Let's see here. Len axes. Hi, Steve. I've seen a lot of chatter about the so-called Norlon trough, which we just talked about. Is it possible no one will know where the trough sets up until Friday morning when the snow has already started, or will you and other forecasters have a good handle on it by Thursday night? I think we already have a good idea of the region where it's most likely to hit, which we detailed here. In terms of the details of whether or not Freehold gets 8 inches or Mount Laurel gets 3 inches, don't know. That really depends on the banding. That really depends on how the storm evolves. I know where the risk is. I know where the most likely... Let me put it this way. We know where the best potential for high amounts of snow are, and we know where they're not. Where they're not is New York City. Where they're not is the Poconos, northern New Jersey. That's light snow. We know there's a high threat for Philadelphia, southeastern Pennsylvania. I know you guys constantly get missed out and There's always somebody from southeastern Pennsylvania ticked off that they didn't get the snow they want at every storm. I don't know why, but it's true. But this one, you have a good shot. So we know where in general, based on the way that the overall pattern is setting up. I don't know specifically that X, Y, and Z is going to get this much snow at this specific location. That's why we have a snowfall range. Are the MJO phases that are forecast locked in? The MJO phases for 4, 5, and 6 are pretty much locked in. There's a very strong agreement. There is a huge debate whether or not the MJO skyrockets through phase 7, lingers in phase 7, and that's going to be a big factor in determining what happens in February, because if it shoots right into phase 8, we're going to rapidly change over back to a cold and stormy pattern. If it lingers in phase 7, it might take an extra week until it gets into phase 8, and then February gets very cold and active. So that's still very much up in the air, and when you're talking about the MJO that far out, there is a lot of volatility. So we know that it's heading towards phase 7 and 8. We don't know how fast that evolves and how strong the MJO wave will be. That has immense volatility within the forecast. Also, it's like there's some hefty warming at 10 millibars. There is. There's major stratospheric warming going on, to the point where the upper level winds, the stratospheric winds, are reversing, but it's reversing at 10 millibars. It's very weak at 50 millibars and barely has an echo at 100 millibars. So there will be influence on the 500 millibar pattern, which is why I'm pretty confident that we'll see that return to a stormy pattern in February. I'm not confident on a strong negative NAO, but I like the idea of a weak negative NAO, especially for mid and late February. And I like the idea of a negative EPO, which is a ridge around Alaska and a trough around the Aleutians. I like that idea. The question is pretty much whether or not they combine. February can be a very, very devious month for El Nino winters, because a lot of El Nino winters typically has that February major finish where you get one blockbuster storm that just you remember for a very long time. In the last storm, there were a lot of freezing rain where the warm pockets were just above the surface that caused that we ended up getting a healthy ice coating. Yep. And it was pretty icy. Yes, it was. Keep the snow coming through early to the end of February, please. That's Snow Boss. Hey, you've got to be happy. You asked for snow, I delivered. It's about 2 years late, but it had finally happened. SREF trended north. Use caution with the SREF. It's an extended old NAM parameter. I typically don't like using the SREF. And recently, I like using the HRR and NAM. The SREF is okay, but it tends to have some issues. And also, if you have any model guides that trends north, I don't know what trend north means, but when you're looking at a model, at a Meso-scale model, ask yourself, does this matches up to all the other lifting parameters in the Synoptic models? So, for example, if you have your strongest bands in the Meso-scale model up by Long Island, well, the first question you have to ask yourself is, how does it support the lifting up there? So, for example, in order to have that, you have to have the jet streak basically centered over central New Jersey. Does any other Synoptic model support that solution? If it doesn't, you probably should throw that out, because it doesn't match up with all of the large-scale lifting that's going on. So that's a key factor here. You want to look at the large-scale lifting. You have to understand what that encompasses, what that supports. Then, now that you got that idea, that general idea, then you look at the smaller tools for your Meso-scale lifting and say, okay, what falls under that lifting parameter? What makes sense given what we know from all the other Synoptic models? And remember, the Meso-scale models tend not do not handle synoptic scale questions very easily. So if you have a model that bucks the trend, that bucks the overall theme in all the other guidance, the question you have to ask first is, where's the error in that guidance? And why does it not match up with all the synoptic models? So that should be a warning sign. Steve, this is my favorite chat ever. Love how you're basically walking us through your entire process. Yeah, I kind of enjoy it. I don't know. It kind of feels like being a teacher. It's kind of fun. What are the chances this comes more north than where it is now on the models? What you need to see is a shift in the jet streaks, which is why I'm waiting till tomorrow to issue the public forecast. Honestly, at this point, synoptically, it's pretty well locked in. But if you're looking for a quote-unquote trend north, what you'd want to do is see that placement of the jet streaks to set up the whole stretching mechanism in the first place to be positioned further north. No long range thoughts. I mean, I got enough to handle right now. So no, I mean, I'll focus. I got next week. We could talk all about long range thoughts when there is nothing going on, probably. But I will say that we will be heading towards a warming trend. Also, premium members, check out the long range thoughts that I wrote about that as well with the MJO analysis.
Like I said before, you gotta sleep at some point.
Yeah, exactly. Could you see someone in the 48 range, 4 to 8 range, end up getting only like 2 inches because of banding? Yep, we just talked about that. I swear sometimes I do this for this chat and I already answer some of the questions. Is there a chance that someone gets more than 8 inches under that heavy band? I don't want to say yes right now, only because the QPF that's involved here, I saw at most about half an inch. So half an inch, if you get some bands producing 20-to-1 ratio, yeah, that could get you to 10 inches, but it would have to be for a prolonged period of time, and I'm not seeing data to support that type of evolution. Is it possible? Yes, but it's not supported enough for me to put it in a forecast as a certainty. It's something that more like I'll be keeping an eye on as I'm doing my live updates that I'll do every hour, like as you know. Let's see here. How wide this band will be. Not sure exactly. Usually in these type of bands, you're talking about maybe 5 to 7 miles wide. Pretty long, though. So the band could go from, let's say, from the Jersey Shore, let's say Toms River, back to Philadelphia. But it could range from, let's say, Freehold down to, let's say, Little Egg Harbor, and then back towards maybe parts of Wellington. So sometimes it could be really, really small. Sometimes it could be really wide. It's just kind of something we have to watch via nowcasting. How cold and windy will it be on Saturday? 20s and winds from the northwest at 10 to 20 miles per hour, which is going to feel more like the lower teens and single digits. What time of day affect accumulation? Not this time of year. No, time of day will not affect accumulations. Give it about 6 weeks and we'll be having that discussion. You know, especially like late February and March where the sun angle is much higher. That's when we'll have more of those discussions about time of day and effect on accumulation. But right now the sun angle is still too low. It would be great to send a backbreak alert in case where freezing rain is about to be unexpectedly falling on top of the snow, like the past event, or wet snow followed by Arctic. I will tell you this, that after the snowfall, everything will refreeze. So it's going to be, you know, I wouldn't say a powdery snowfall. It's kind of in between wet and powdery. How about ocean effect snow bands like the bands coming off the ocean and Monmouth and Ocean counties with stretching from the low offshore? That's part of the process that we're going to be dealing with here. The northeasterly wind is going to be coming off of the Atlantic Ocean. That's what's going to be feeding our moisture. The stretching process is what's going to be enhancing that process and setting up your banding. So that is going to be part of the process, the ocean effect of taking. That's where we're getting all our moisture from. That's where I was showing that stretching. With 2003, bless you, was 2003 an El Nino year? I honestly do not remember right now. I'll have to research that later, Card. Dan, let's see here. Dan says, great coverage before, during, and after last storm. Steve, great live updates, personal support for my business. Keep up the great work. Thank you. Fred asks, historically, some inverted troughs have done crazy things. In 1988, a narrow corridor in Long Island got a foot of snow, while surrounding areas got 2 to 4 inches. Way more recently, December 2019, I remember this. There was an inverted trough crushed down by Atlantic City, 5 to 8 inches. National Weather Service was doing 1 to 2 inches. I remember this. I was watching this. I'm like, oh my God. Yeah, inverted troughs can be pretty nasty. They could create a lot of volatility. Which meso models do you trust more for this forecast? I like using the HRR and the NAM so far. They match up pretty well with what's going on synoptically. And synoptically, I've been using a mix of the European ensembles and the Canadian. GFS isn't too far off either, so it's not doing too bad. But I like those models, but I don't like the moisture profiles on those models compared to what's going on with the Meso-scales. So I kind of did a blend with that. That's all the questions for now in the premium chat. Let me go check out what's going on YouTube here.
Twitter's busy too.
Whew.
Twitter, whatever it is.
Let's see here. I noticed that forecast models spot a winter storm 7 to 10 days out, 4 to 5 days out, they lose it, and then 3 to 1 days. Why does that happen? Okay. So the reason why that happens is because the models 7 to 10 days out are picking out the general theme. Then let's say 4 to 6 days out, they have trouble resolving all the different short waves. And then once you get under 5 days out, then you start getting a better idea of the short waves you're handling within that pattern. This is why I say after the 5 day period, what you'd want to do is just study the overall pattern. Under the 5 day period, that's when you start to nail down the details. Under 90 hours is when you can start really pinpoint precipitation amounts, wind impacts, stuff like that. Let's see. Peace and love. Da-da. Steve's wearing the shirt. Let's see. There's some good questions, a lot of points here. I'm trying to find the best one. A lot of great stuff here. A lot of stuff I already went over. Wow, this is a lot of questions. Holy smokes. Thank you for including Delaware. Yeah, no problem. Let's see. What is the MJ? Okay, the MJO is a Madden-Julian oscillation. This is a small scale wave that moves across the tropics that enhances tropical convection, tropical thunderstorms. And how it enhances tropical thunderstorms influences the way that the jet streams evolve, and it influences our weather as a result. So there are 8 phases within the MJO. And each phase creates a unique impact on the 500 millibar pattern. It's not always the end-all be-all, but it's an important ingredient when you're making your cake and trying to figure out what's going on with the weather pattern. Will the models trend northwest with this storm? That's a great... Okay, so models in general are going to be adjusting a little bit with the impacts. which is why I expect to make some minor changes to the forecast. But again, there's pretty strong agreement synoptically where the strongest lifting is going to be focused. Now it's just a matter of trying to make those adjustments. And, could there be a shift in the placement of the upper level winds? Absolutely. We'll have to keep an eye on that, see where that's set up. But right now, I have no data to support that synoptically. Let's see here. Was this setup close to a major East Coast snowstorm type of event? No. And the reason why we knew it wasn't the minute we saw the orientation of the trough being positive tilt and the location of the ridge over the west. The minute it wasn't over the Rockies and wasn't building, we knew that it wasn't a pattern supported for a major East Coast snowstorm. Miles don't trend northwest. This is what people see is the adjustments based on the interaction of short waves. Earlier on in the fall, there was several miles adjusting to a stronger wave of low pressure on the coastal plain. Some would say it was adjusting southeast. What you were seeing was mild guidance was handling the short waves in the polar and subtropical jet stream, and you were seeing those adjustments based on the handling of the individual short waves. In this scenario, though, the short waves are already in very good sampled areas, so that's already been adjusted for. And I don't do school cancellations for school. I don't try to figure out what school administrators tried to do. Especially now with homeschooling. Like you could do like the schooling on the internet and stuff.
It's outside of your scope.
Yep. Do you think there'll be a huge dry slot issues? Dry slot, we have to be careful with that term. Okay, so dry slot in terms of precipitation getting cut off occurs when a 700 millibar low is passing over your region. So all your heavy precipitation's off to your west and to your north. In this scenario, you could get a reduction of precipitation because of strong lifting to the north of you or to the south of you. That's not the same thing. That process can definitely happen, and we just talked about that tonight. Yeah, I understand. A lot of people want to see a coastal bomb. I get it. Let's see here. So a lot of the same questions. Does the amount of snowpack influence these types of forecasts? Yes. In terms of the thermal gradient that we have involved here from the coastal plain to the Atlantic Ocean, it certainly enhances that process and the frontogenesis process, which is probably going to help to enhance some of these bands. Will snowflakes be fatter? Closer to the coast they will be. Yes, because you're going to have warmer conditions and more moisture. Anyway, we doubled totals in some place. Surprise. One guy has 12 inches or more if certain things work out. My problem with 12 inches or more is that, okay, in order for me to forecast that, given the amount of time that we have and the time period where there's going to be the most supportive convective lifting, I need a band that's going to produce over 3 inches per hour. I don't have data. Is it possible, in the realm of possibility, is it possible to pull that off? Yes. So is me winning the lottery. That doesn't mean it's going to happen. That's really, really hard to pull off, to go that much. I don't see any support for that in the QPF. I don't see any support for that in the intense lifting. So I would. That's why I wouldn't touch that height. Could it happen? Yeah, I mean, if you got a really, really intense band and it really just went crazy, 3 to 5 inches per hour, right? But I don't have any data to support that. So will I be on the lookout for it, given what I'm seeing? Sure, I have it in the back of my mind just to keep an eye on it, keep an eye on rates, so on and so forth. Would I forecast that? No, not what I have. I don't have that. There's no legitimate data to make that announcement, to make that type of forecast. I could squeeze out 8 inches because I got half an inch QPF on a lot of models around central and southern New Jersey. And if you get banding, you can get up to 20-to-1 ratio for a short period of time, not for the whole time, but for a short period of time. So then that could get you up to that 7-8 inch level. I don't have any data to push me above 0.5 inches in QPF. That's the amount of moisture. And I don't have any data to support the type of intense lifting you would need to produce a 3-inch per hour snowfall rate. So that's why I wouldn't go that route. Other people could. Other people have their own forecasts, and that's fine. People got to do what they got to do. Let's see here. How's Long Island looking? Well, snow showers. About 1 to 3 inches. Not a big deal in Long Island right now. We'll see. We'll keep an eye and see what the 0Z model guidance shows. And I understand, let's see if we have new 0Z guidance out yet. Let's see if the HRR is out. Well, let's see here. 0Z. Let's see what it's showing here. I'm using Tropical Tidbits, by the way. Let me actually show it. That'd probably be a good idea, right? Okay, so let's see here. This is the 0Z HR. There's our banding. Right there. Produces several bands. Impressive. This goes out to about 46 hours right now. Okay, let's see what that looks like. Okay, so based on this is the new HRR. You have that convective lifting. Again, if I was looking for like a 3-inch per hour, I'd want this a lot more sharper, right? Because then that'd be like really intense instability. I don't see that. That's not here. So I'm not going to forecast that. But certainly some pretty good banding. Let's see. Good equivalent ratio. Omega values are around -1, so pretty strong lifting at the lower levels. Okay, so let's see what this looks like in terms of total snowfall. It looks like it's not showing up very well. Oh, I see why. It's not showing the full forecast yet. See total positive snowfall. Okay, that part isn't out yet. So it's only as far out as the radar depiction, which is fine. It gives me what I need. I wonder if it has accumulated. Ah, this is beautiful. Okay. So it's producing that band here. This is an interesting signal up towards northern New Jersey. We'll have to see whether that keeps on showing up. You got another sign of a band here. This could be... I wonder if that could... Okay, that signal right there, that could be stretching on the back end of this precipitation shield via like a deformation zone. Not really that well supported on the Synoptic models for a deformation zone to show up as it swings on through. But that's something I'm definitely going to be watching out for the other 0Z model guidance, like for the NAM and the European and the GFS, to see if there's any signals showing up, or if this is just an error on the HRR. So that's certainly something that we're going to put a pin on and keep an eye on as maybe a back end gradient. Very sharp gradient too in the precipitation shield. So that's pretty interesting. So you have your strong lifting here, you have your snow bands here, and then this anomaly here that showed up that's different from Let's see, at 18Z, we didn't see anything like that. You had all the focus down here. You had signs of sinking air down here. So it's definitely something that we're going to have to watch out for the rest of the 0Z guidance and see how that plays out. So that's a nice little interesting signal up there. Let's see. We got more questions here in the chat room. Let's see here. And a lot of questions about HR. Let's see here. New 0Z HRR is out. Just did an internet search. 2002-3 was an El Nino year. Yep. That was a big February storm. That's true. Latest HRR seems to get the rain further inland than you forecasted. Are you concerned the model is overdoing the warm surge? I think I need to see more data. I'll probably follow up on it tomorrow morning. That warm air push. Well, let me see if I can see. How does it do it? Okay. Okay, there it is. Okay, so what the model's trying to do here, what the HRR is trying to do here, is close off an 850 millibar low. And when it does that, see these winds coming in from the east? It drives in that warm air. So let's see. Let me try to pull up. Now, in other guidance, we do not have a closed 850 millibar low. Like here on the European, no sign of that. And let me get rid of this. 850 millibars. Let's see. Let's see if there's any other models. We'll pick the GFS. See if the GFS has anything like that. The GFS keeps an open trough icon. Try the icon. What I'm doing is I'm walking through synoptic models. Does it make sense synoptically? And the icon tries to close it off, but then loses it. Korean. What the hell? Korean keeps it open. So out of the model guidance that we have available, only one barely closes it off and everything else keeps it open. So when we compare that to what the HRR is doing, it doesn't have a lot of synoptic support. So this would be a red sign. This would be a warning sign for me. Seeing this close and see this strong. See, like if we had an 850 millibar low sitting right over the Delaware River, that would make sense. But the reason why you don't see that in other guidance in that type of warming is because that doesn't happen here on the European. So that's one thing we're going to be looking for with the 0Z guidance tomorrow morning on the European guidance and the GFS guidance is whether or not we close off at 850 millibar low on Friday afternoon. What resolution do you prefer on the NAM? About 6 to 12 hours out, I like using the 3 kilometer. At this level, I like using the 12. Winter 77-78 was an El Nino year with 2 big February storms. That's true. February, do not sleep on February. That's the key lesson here. New 0Z HRR is a bit, yep, we just talked about that. Will the banding be moving more north and south or east and west? The banding is going to move in, let's see here. It's going to come in from the Atlantic and then drop south. So let's say it'll come into Monmouth County and then kind of pinwheel southward through the Jersey Shore. I don't. The I'm guessing NWS. I got my own forecast. I don't. I don't like to critique other people's forecasts. The National Weather Service, whoever, because they have their own thoughts and then they go about their own thing. And I prefer they have their own forecast discussions and whatnot, and I prefer them to answer for their own forecasts rather than me critiquing their forecast. They obviously believe whatever they have written there, but it's just like from a meteorology point of view, for other meteorologists, some other meteorologists have different ideas. They see the same data and have different ideas on how to handle that data. So it's really bad form for me to go around and say, well, this one's right or this one's wrong or so on and so forth. I just leave that alone. It's easier for you guys because, like, it's kind of like professional courtesy. Okay? So I have my forecast. I'm sure they have their forecast. They do their own thing. Let's see if there's anything else showing up on YouTube.
Are you able to see Twitter?
Let's see here. Let me go back to it real fast. I got 2 questions here.
You might need to refresh it because you got a whole line of stuff that should be.
View engagement. I guess it didn't show up very well. I don't know. I wonder. Oh, there it is. I think.
You're funny. Here, let me come over and see if I can help.
I know it doesn't show up very well on the desktop for some reason.
I'm not surprised. We'll have to troubleshoot it, like so many other things.
Yeah, X is doing X things.
Alright, so do you want me to come over there then?
Yeah.
Alright. I shall allow you to scroll through and figure out what you want to answer.
Okay, let's see here. Let's see. Good evening, sir. Let's see. Okay. What time should we expect snow? They asked for Philly, but in general, we'll start up with very light snow after midnight. Like, let's say 11 p.m. to 2 a.m. You're going to get snow showers breaking out. Steady snow towards the morning hours. So let's say 6 a.m. You'll start to see more and more light snow breaking out. Nice job working through the process. With weakening El Nino recent stratospheric warming, does this increase volatility for February and March? More so for February, not so much for March just yet. Let's see here. Great camera quality. Yeah, I'm kind of screwing around with the camera. See if I can fix it even better. Let's see. Check out 0ZHRR. We already did. Let's see. Is it possible New York City gets more than 1 to 3 inches? I don't think so right now. Keyword right now. Take a look at the rest of the data later. Let's see. So tomorrow I will have the public map out so you could see exactly. I think that's all the questions. Most of it was how much in X, Y, and Z.
Yeah, I noticed.
So let's see. All right, I want to see. The last thing I want to check, and then I'm going to call it a night. Is see if the new NAM came in yet. And we got some new data here. So okay, you know what? I'll tell you what. Let's work with the NAM and take a look at the upper level dynamics. 250 millibar winds. We'll start with that and see whether it works out with the Synoptic models. So let's see here. This is only going out to 28 hours, so it's not exactly where we want it to be. We do have some of that strong signal out here, but it's not far enough out yet to really do a very good analysis. Let's see. 850 millibar winds. Let's see. Let's see if maybe some other guidance, other locations might have. Yeah, everything's out to 28 hours. So, fortunately, we don't have all the way out to NAM, but we will check that out later on. Probably it's going to be another 40 minutes, and I don't think I can go that long. So, let's see. One more question. Any potential for urban heat island to impact convection on Friday in areas that are in the Norline Trough area? Yeah, it's going to be an interesting question to solve and something very interesting to watch in Philadelphia, especially around the Delaware River Valley. Just keep that in the back of your mind. That could be pretty interesting around Burlington County, Monmouth County, and Ocean County. That could be a very interesting factor to see that evolution. But I think, let's see here. Yeah, everyone else, let's see here. Looking at the new NAM, it has a stronger ridge and a bit more amped. If I'm looking at it properly, let's see here. Okay, so let's see if we can zoom out here, just so I can see what people are talking about. Con US. And this is out to 32 hours. Okay, so I'm not seeing the trough being stronger or weaker. It kind of concerns me that there's missing data here. That ought to be a bit of a warning sign. I don't know whether that's just a website thing or that's a missing data thing with the model. 250 millibar winds. Okay, let's see here. Jet streak is where I want to be. Very strong too. Pretty much what exactly I'd want to look for. Lower dynamics, front of Genesis. Front of Genesis showing up pretty well. Refresh this. So yeah. We're going to take a look and see what the I'm not going to comment on other people's take on the storm. We'll leave that alone. Okay, so it's 9:12 and I'm starting to lose my voice. I think I pretty much went over how I went about making this forecast, what we're going to be watching for, and what we're going to be analyzing with the 0Z guidance, all of the 0Z guidance. You do not want to change your forecast based on looking at one model and then that's it. You have to look at all the guidance and kind of get an idea of basically what I just did, what I walked through with you tonight. So we'll have the public map out tomorrow morning after I look at all of the data. You guys, since you were able to watch it, you saw me put together the map and show how I put together the forecast. So now, when you see the map tomorrow morning, when I issue it publicly for everybody else, you'll understand how I went about making that map and how I went about making the forecast. And I think that is that for tonight. Thank you as always for watching. I really appreciate it. And as always, stay safe out there.